So next we have Michael Kovalcik with KODE Labs, going to get into build smarter for service, automatic alarms, faults, testing, and service at scale. Thank you, Michael.
Thank you. Hello, everyone. Welcome to ControlsCon. Also, welcome to Detroit. Hopefully, this is not your first time here for many of you. My name is Michael Kovalcik. I'm a product manager at KODE Labs. Today, I'm going to talk to you about KODE Labs and KODE OS, software platform we're building for smarter service, automating all parts of the building operations stack, but specifically today, alarms, faults, functional testing, and how that ties into service at scale for partners and our clients. The agenda, so I'll just tell you a little bit more about the company. If it is your first time hearing about us, I'll give you a little bit of background on me, and then the majority of today will be a live demo of the platform, walking through the use cases, starting with onboarding a building to setting up alarms, faults, functional testing. And yeah, so about KODE Labs, we were founded in 2017 here in Detroit, Michigan as our headquarters. We've been in business, that's about 8 years now. We've had 0% churn throughout that time. We have 150 different integrations, pre-built integrations to systems, which you'll see throughout the demo, serving over 100 clients, global clients, across multiple different countries and continents. We work across all verticals, Fortune 500, global REITs, retail, mixed-use healthcare, office, data centers, et cetera, and are trusted by some of the largest real estate operators, corporations, retail providers in the United States and North America. As you can see, Hines, Ford, TJX, Quadreal, Empire State, et cetera. A little bit about me. I am born and raised here in Detroit, just outside the city of Detroit. I went to the University of Michigan, and I've been with KODE Labs for 7 years. So I've really saw the evolution of the company from the very early days, just basic cloud BMS software, to what we offer now, which is a full suite of applications for running and managing whole real estate portfolios. I've been on the front lines of project management, doing integrations, working with customers, client experience training, servicing, troubleshooting. So I'm really happy to share, my perspective with this audience today and how we've built the platform. And really, with that being said, I'm going to get into a live demo of the software, again, starting from portfolio onboarding. Our software was always designed to operate at scale, whether that is globally across multiple different continents, nationally within, all across America, or even regionally within a certain city. And I know we all often do business across different markets, or we might be responsible for a different region. The platform, even at a portfolio scale, does scale down to certain users who are regional or building level and can see just what they need to see. I'm going to take us into a building here, walk us through from the first step how we bring equipment, data sources, everything online. So there's a bunch of dashboards, alarms, functional tests, faults, which I'm going to show today. But I'm going to start with our API catalog and how we onboard buildings. In our API catalog, we have over 150 pre-built integrations covering everything like access control, cameras, HVAC controllers, Tritium Niagara, IntelliWeb, Distech, et cetera, EV chargers, elevator systems, IEQ, leak detection, lighting, metering, occupancy, so on and so forth, all the way down to work order systems. Many of these integrations, we do both read and write with these systems. We try to synchronize their data, offer a single pane of glass to not only collect and store data, but also interact back with those technologies. Adding an integration is really simple. I'll just demo this for you with Tritium Niagara as an example. What we do is we click Add Data Source from the API catalog. We're able to input some information. What's the IP address, port, version number? We stand up a VPN, and we're now able to grab every single data point from that Niagara Server or Jace or any of these integrations. It works the same if it's for metering, if it's for IAQ, and it all starts coming back to one centralized platform in KODE OS. The next step, after you add a data source, you've discovered devices, is we're actually going to normalize some data. How Code's philosophy and approach has been, when we bring data in, we need to normalize it. We apply an ontology, we standardize the data, which allows for rapid and scalable activation of all the other features that we're going to see within the platform. Here, this is a live demo. Here I'm in a building. I'm looking at a group of fan coils. I've selected 50 of them. I'm actually going to select 700 fan coils at once. And I'm going to do our point modeling. This is how we normalize the data within our software. And just to kind of explain what we're seeing on the page, in the first column, these are the raw point names that you would find in the BAS at this site. Fan_amps, DA_temperature. And then since we've selected 700 fan coils, we're seeing the number of devices that have that point, how many have been normalized so far, and what field has been applied to them. Our goal is to take this fan_amps at this building and assign it to something that our software can recognize, a discharge fan current sensor. Normally, there's been a lot of different ways of doing this in the industry. I might pick this field and pick from a list, or drag and drop, or add some tags to it. Where we are leaning in more and more is using AI to do this. So I'm going to select, I just selected a handful of points here. I'm going to suggest with AI. It's looking at the raw name of that point in the BAS. It's looking at the min and max values associated with the 700 points that are selected. And it knows about the HVAC and the systems in the building. And it's suggesting fan amps should be called discharge fan current, the discharge air temperature, the DA temp is a discharge air temperature, the fan status is the fan status, and so on and so forth. So this is the step of applying the ontology to the different points and equipment in the building. Once we've normalized it, this unlocks access to the rest of the platform. I'll just show, to understand at a granular level what we are working with. We have, now individual point level data on every device within the building. This is just a floor plan view. You can see we have color-coded zones and a full graphics tool, which I can talk about as well. What I want to highlight here, and if anyone was in the previous session about going to cloud, is we are capturing point level data. We're storing it all in the cloud, so we have 30 days of trending. All this trending happens automatically after we integrate those points for every single integrated data point. You're seeing here the normalized names that we get out of the ontology. Our platform recognizes that this piece of equipment is a fan coil unit, and it has functionalities like zone temperature monitoring, it has chilled water valve control, and so through just that simple labeling of the data, it tells the platform everything we need to know to set up other features, like fault detection diagnostics. Our FDD approach really spans two different categories. We support monitoring and tracking of those critical alarms, those things that you need real-time response to as soon as they happen, whether that's within a commercial property and there's a dedicated team there, if you're servicing it and you need to be informed right away to provide that best service to the client. And we also have a faults interface to track and investigate and be smarter with your service or with your planning to solve recurring issues in your client environments. For any issue that we select, you're going to get automated trending on when the issue started. You'll get some information about where and what piece of equipment it is. And then our system will automatically start analyzing this fault with an AI and a large language model that we have in the background. And it's going to produce a problem, root causes, and likely next steps associated with this. Speed troubleshooting, make it, the primary goal here is let's save time. Save time on analyzing what is this routine, could have caused it, what should we do next. If we can surface this information for you instead of spending 5-10 minutes looking at this device, the parent device, looking at all the different conditions that could have led to this specific case, we still have a need for that. But let's make those people more efficient, and let's make the others who are actually working on resolving these cases also more efficient just by plugging it right in here. The alarm side of the platform can be used to, you analyze this, you get the root cause, you have a multi-point trending feature in here where I can add additional points and go in and investigate even more specifically what the case is. I can push directly to a work order system, whether you have your own CMMS or using our maintenance platform. You can push directly into that, view the history, see who is notified, and leave comments, all within one interface, all without leaving the page. We offer a pre-built library of rules that are available, cover all your most common verticals, all your most common technologies, HVAC lighting for commercial, retail, et cetera, verticals. And we also offer a free form custom rule builder so that you can customize to those specialty cases, specialty technologies that might be in the building. The other side of fault detection diagnostics, and you can see on portfolio level view, jumping from one building to the next, this is how easy it is to monitor and manage properties across many different buildings. The other aspect of fault detection diagnostics gets into analyzing the long-term trends and behavior faults, making sure that we have the right analytics to see what's been happening over time here, what's been happening on this entire device, having the ability to assign different users to this, leave comments, trend additional points, and mark things as suppressed or through different statuses. It's really a tool where now you can plan your work when you go to these different properties. I'll continue next into our functional testing side of the platform. Functional testing is a digital commissioning tool. What we're doing is we're writing pre-programmed a testing sequence. Most commonly, we're going to stroke a damper, stroke a valve on a terminal unit, but also on an air handling unit. We're controlling fans, dampers, heating components, cooling components to test and validate that the equipment is actually functioning as intended. This is being used all over the place. It's being used on any sort of retrofit or new construction. Anytime new equipment's being installed, you want an automated way to test and verify it's working as expected, so you can get out of projects faster, you can deliver better service to your client, and then it turns into a continuous commissioning tool that can be used for the rest of the service contract to proactively identify issues within your client's equipment. Here we're looking at a portfolio view. Over 2,000 tests have been executed in the last 30 days across a number of different buildings. Like I said, some of the common tests are for stuck dampers, damper operation, heating, cooling capability. I'm going to walk us through just what a typical test might look like, and then also show example how this ties into the workflow. So this was testing a fan coil for its heating capability. This test did pass. We're printing out initial conditions. We do precondition checks, things like, do we have pressure from the loop? Is the fan running? We're going to automatically stop the cooling. We leverage KODE's ability to write to equipment and command and control it to force this equipment to override it into a state where it's no longer cooling. We make sure temperature rises and it meets our criteria. And then we're gonna command that hot water valve to 100% and ensure that it does open up and does actually begin operating as expected. This is a huge test that we see used seasonally when we switch from heating to cooling season or cooling season to heating season. You proactively stroke hot water valves, chilled water valves, electric heat components. Is that piece of equipment capable of putting out the heating or cooling that I need? Now, in May, before we get to July and August, and I'm gonna have the hottest days of the year, now that tenant complaint is gonna be coming in. So it's a really effective service tool for proactively identifying opportunities. Here, I have a similar test. This is a stuck damper test. Just very simple. We're stroking the damper closed and open and seeing if we hit the appropriate airflow levels. Anytime one of these tests fail, we do have that same capability where we are automatically analyzing this scenario with our AI engine. We are looking at the specific details of this test. We're looking at all the other tests that were performed in this building, on this floor, for this particular stuck damper. So we're looking at, is it a systemic issue or is it really isolated to this device? We're looking at the points, the point trends. What is this VAV's ability to modulate and control airflow? All these roll up into a large language model, which provides this simple, straightforward, here's what the problem is, here's the likely root causes, with confidence intervals on each of those root causes, and the recommended next steps that would tie back to a technician or a service operator for these cases. You can push work orders directly from here to your service platform or, again, our maintenance platform. You can schedule these types of tests proactively in advance. They can be monthly, quarterly. They typically happen during the working day. Monday or Friday and late in the afternoon are some of the best practices we've seen from our clients about being able to test and commission their systems. You can use it immediately after a service visit to sign off that the service we provided has restored functionality to this piece of equipment. It's really as simple as either scheduling in advance or going to that device and clicking run test now, and it'll automate this report for you. What we've seen so far within KODE has really been the API library, the integration of the data points, and the modeling, turning that into alarms and functional testing. I want to take you next into BI dashboards, data visualization, reporting, and communication out to the building team or your own team. We've created a variety of dashboards within KODE OS. Typically, our clients are creating templates that they want to scale across their portfolio. We have out-of-the-box templates that we also use. So when you use KODE OS, you have templates for each vertical, commercial, retail, healthcare, and then you can customize or create your own templates as needed to suit your particular client base. Here, this is an operations dashboard. We're using all that granular level HVAC data to highlight key information about the building, how many boilers and chillers are running, what's the total cooling request, and key temperatures across our systems. And we have a number of, you can dive deeper into these pages. We have different dashboards, which I will show some throughout this presentation as well. But the new introduction we're making is we've also added an AI assistant into our platform, which will automatically analyze the dashboard content that's in front of you, highlighting any status and efficiency remarks, pointing out temperature, energy consumption items. It might suggest ways that you can improve. This happens automatically as you navigate between different dashboards. It's going to read each one and start thinking just as you navigate the platform. Everything we've seen today was built in-house by KODE Labs. We developed 100% of the platform, including our BI tool, including our fault detection diagnostics, the functional testing, our API integrations library. While I'm here on the BI dashboards, I will point out that the flexibility that we have, our typical approach at KODE Labs is we build tools that we use, that partners and contractors and even ourselves use to go deliver that end client interface. So everything that we do within BI, it's not, you do have templates, but we're using the same set of tools, the same sets of charts, data sources, and metrics that our team has access to create extremely powerful KPIs, metrics to report on the health of the building, whether it's connectivity, overrides, operations, or even getting into energy and work orders. All of it is done within the platform. So we have, BI reporting at the building level, at the portfolio level. You saw a bit that we have floor plans and devices. We also offer full system graphics, which are built in KODE OS just like everything else. Here we're looking at a chiller plant. You're looking at, tables and pumps and pipes and chillers, which are all drawn using our platform. This is another area where we are embedding our AI assistant to automatically analyze the performance of this chiller system, the real-time status, calling out any areas of concern, any positive trends, things that might be indicators of what is going well. These all, again, update live. The instant you load the page, you can see this information. You can command and control from here. You can make the adjustments. And this is typically what's being delivered as part of the then end interface. I will just highlight here briefly the edit mode that, really all these components are selectable. We have a library of HVAC elements. You have the ability to upload your own and kind of scale that across your different deployments. You can draw on the floor plans. We support zones, ductwork, all this. A really flexible, powerful graphics tool built to be integrated with data, to be integrated with AI, all in one place on top of a normalized ontology. What you see more at the device level, one thing I just really have to emphasize is the repeated scalability of this, how quickly graphics, fault detection, functional testing, BI dashboards, everything gets turned on rapidly. As soon as you normalize that data, we can tell you instantly which of these things that piece of equipment is now compatible with. We can start flowing and reporting KPIs on it. And so setting up KODE OS becomes more of a, you do the initial data modeling, which is being done even more with AI now, and then it becomes a checkout process. I want these dashboards, these templates, this FDD here, click, 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 and it is essentially configured for you with the ability to tweak it. This goes even further into device graphics. We were looking at a floor plan before. Every fan coil in this building has a device graphic associated with it as well. This is scaled as part of a template. You draw the graphic once, you put the points once, it automatically applies and configures for you there as well. These are the primary use cases on analyzing the building and its data. How does this really tie back also to the service side? Is we looked mainly at HVAC, but we integrate with work order systems where we do both read and write control into these platforms. You saw from FDD and FTT the ability to create a work order there. Here's a report looking at work orders from this property. Distributions of people, who is assigned to, what the different statuses are, daily trends, and heat maps into what types of problems we're having on what floors. This is just one little lens and BI report into what we do for maintenance and work orders, but we also have a maintenance platform. This allows you to do preventative maintenance and scheduled, asset management across your different properties or client bases. Here we're looking at just a simple dashboard for preventive maintenance, showing the task calendar heat map associated with this site. I can drill into preventative maintenance, see a list of tasks. This is really even more optimized for mobile. When you're on site and doing that service, you have your predefined list associated with this. You can see for each piece of equipment what exactly are the steps that you need to do as part of preventative maintenance. Update them here. You do, especially on mobile, have the ability to upload attachments, notes, mark the completion of these things. It does also tie back and integrate with work orders. This platform is compatible. It is connected and can integrate with work order systems and be synchronized with what you have today, or it can be used as a lightweight preventative maintenance asset management platform to run your building operations. All this together turns into a pretty powerful package for servicing and optimizing buildings. You can rapidly onboard and integrate. We sit on top of all existing types of technology. We integrate super well with Tritium and many of those other BMS systems. We have a very fast and intuitive normalization framework, which unlocks pretty rapidly fault detection diagnostics, functional testing, reporting, energy metrics and KPIs, the ability to integrate with maintenance, all from a single platform. And how we're really driving, or how our product and technology is really driving change in the industry, is it's leading towards smarter service contracts. Our partners that are using KODE OS to provide service to their clients are more efficient in how they troubleshoot. They provide better service with that one resource has more time. We know it's tough to find good people, and when you can save time for them, you cut down a little bit of their analysis, so you're prompting them with some likely root causes that they can just review and agree with in a minute versus having to do all the clicks. When you give them functional tests that are gonna call out where the issues are proactively, or BI reporting, or system graphics, all in one place, tied and integrated with maintenance platforms or work order systems, it is really driving to an increase in efficiency for our partners and better service for their clients and higher margin for our partners, which is allowing them to actually scale and distribute the platform. So this is primarily what we had to talk about today. If there's any other questions, there's a couple minutes, so I'm happy to take questions on anything about KODE Labs or KODE OS.
Any questions?
It may be a little off subject, but you said that you integrate with a lot of different platforms. Can you imagine that one day you guys can integrate data from human resources, places like Workday or PeopleSoft? And the reason that I ask that is because everything that we do is to service people. Mm-hmm. And if we have some way to get information about the people, whether this group is going to this department, or this department is in this day, or these people are in that day, that information could somehow correlate to all the other data and be valuable at some point.
Yeah, great question. We are seeing use cases like this. One first way that shows up is integrating with work order data, tenant complaints. Tenant complaints, if you get too many hot calls or cold calls within a specific floor or area of the building, we can orchestrate the functional testing of that equipment. Hey, everybody is complaining it's hot here. Let's test it for its cooling capability. Automatic result to now potentially even close those complaints. The other way that it shows up, we do a lot of integrations with occupancy sensors, desk level sensors. They come with additional information on what type of space is this? Is this a conference room? What's the utilization of our rooms? So really the smarter office portfolio, advanced portfolios are leaning more and more into this. How are people using our spaces? What's the comfort and temperature in those conditions? And they are looking to optimize that. So I think it's only gonna become more and more advanced what we do. And we're building the tool set to scale for those use cases.
So Workday is actually in the queue right now. Oh, really? And it was requested by, I believe, Harris Mechanical. Is it working Workday's in the queue right now. It should be done probably the next 60 days or so. There's different parts of it, but we are already seeing a lot of use cases like that. It just, there's different regions and locations that you have to watch out based on obviously different laws and regulations based on what type of information you can grab from it. But yeah, we're seeing a lot of those use cases start. I wouldn't say a lot, but some of those use cases starting to come around because of what Michael was just talking about.
Any other questions? Great job, Michael.